Welcome to qnawire.
Here the question is, the complex ion NiCl4 2 negative has 2 unpaired electrons, whereas NiCl4 2 negative is diamagnetic. Propose structures for these two complex ions. So first we are taking NiCl4 2 negative. In this complex, we know one thing, that Cl minus is weak ligand. And when it is weak ligand, crystal field splitting energy will be less. Now, how the electrons are arranged in it. Atomic number of nickel is 28. Outer electronic configuration is, after Ar, it should be 4s2 3d8. And when nickel is at +2 state, its configuration is 4s0 3d8. So, how the splitting is taking place? When the coordination number is 4, splitting is just opposite of octahedral splitting. So, dx square minus y square and dz square will be lower energy level, and dxy, dyz and dxz will be higher level, but this splitting energy delta E, delta 0 should be less in case of Cl complex, and that is why the electronic configuration should be, electrons are first filled singly and then pairing is taking place. So 8 electrons we have to arrange, 1, 2, 3, 4, 5, then 6, 7, 8, and by this we can understand that how in nickel chlorine complex, first complex, 2 unpaired electrons are present, and because of that it should be paramagnetic. Now when it is paramagnetic, d orbitals are not disturbed. That means the hybridization should be sp3. When hybridization is sp3, the geometry is tetrahedral. Nickel at the center, and all the chlorine, one chlorine should be above the plane, other chlorine should be below the plane, and all other chlorine are arranged tetrahedrally, and this whole complex should be inside the bracket, and outside it should be 2 negative. So geometry is tetrahedral, and hybridization is sp3 in case of first complex. Now in second complex, what happens? Complex is NiCN4. So when the complex is N nickel CN4, CN ligand, we know already that it is strong ligand. -2 should be the charge over it. And here, when CN is strong ligand, splitting should be maximum. That means more than the chlorine. So splitting, we can draw the diagram, and it should be more. So we can make it the lower energies here. And this is showing clearly that CN is strong ligand and splitting is more here. Splitting energy is more. And when it is a question of 8 electrons we have to arrange here, then first lower energy levels are filled, then pairing is taking place, and after that 1, 2, 3, 4 and 4, 8 electrons are arranged here like this. The reason is here CN is strong ligand and the hybridization is here DsP2. So we have to spare one d orbital. This should be vacant for the hybridization, and because of that all the electrons are paired here and the complex is diamagnetic. When the hybridization is DsP2, then geometry should be square planar. So nickel at the center, all CN and the central atom are in the same plane. So this can very well explain how the complex is diamagnetic and what should be the geometry. To make the hybridization DsP2 and square planar geometry, one d orbital is needed and that should be vacant. To make it so, electrons are paired in the inner orbitals and all the electrons are paired, that is why it is diamagnetic. Hybridization is DsP2 and the geometry is square planar.